Hello everyone, my name is Julia Bird and I am a STEM ambassador for the University of Memphis. Today we will be using cabbage juice as a pH indicator. So what you will need for this experiment are one red cabbage. Here I still have it in this deli bag. This is kind of what it looks like here. More purple than red, but I didn't make up the name, so. You will also need one bowl, some water, and then you will need a basic substance, a neutral substance, and an acidic substance. Here on the right, I have a pH scale, and then for each level, we have something in your house that will be on the scale. I would not recommend using batteries for the experiment, nor stomach acid, but anything else on this list is very appropriate. So before we start our experiment, I'd like to go ahead and talk about some background on water. So water, the chemical formula is H2O, but it is constantly self-ionizing or breaking into charged particles. So here we have our hydrogen, it is H+, and then we have our hydroxide, which is OH-. When acids and bases are added to water, water reacts appropriately. So for acids, there will be a higher hydrogen concentration than OH concentration. For bases, there will be a higher OH concentration than H+ concentration. And then in neutral substances, you will have equal amounts of both. So what are acids and bases? An acid can donate a hydrogen, and weak acids, there are two different kinds of acids, weak acids and strong acids. Weak acids, they do not donate all of their hydrogen atoms, but strong acids do. And bases kind of work, very similarly. Bases are the exact opposite of acids. Bases can accept hydrogens, weak bases accept some hydrogens, and strong bases accept many hydrogens. And here on the right, you can kind of see where an acid is donating a proton to the base. Okay, and what is pH? So pH is defined as the concentration of hydrogen atoms in a solution. So more hydrogen, as we discussed before, and less OH means that something is acidic, less hydrogen, more hydroxide's basic, equal amounts of hydrogen and hydroxide means it's neutral. And why can we use red cabbage as an indicator? I promise we're about to get to the experiment, but this is very important. So again, on the right, we have a pH scale. It goes from 0 to 14. And each way along the scale, it tells how many hydroxides, hydrogens, 0 having the highest concentration of hydrogen, and 14 having the least concentration of hydrogens. And this red cabbage juice, it contains a pigment called anthocyanin. And anthocyanin, it reacts with acids and bases, and you can see, based on the colors, how high the concentration is. So now we'll go ahead and jump right into it. Okay, so I have my bowl here. And now I'm just going to pick off some of these red cabbage leaves, oops, with my hands. There's no magic number here, but I mean, the more the merrier, right? Just gonna toss it right on in there. Really just put as many as you want. This looks pretty good. So now I am going to fill my bowl over the top of the cabbage with water, and I'm going to put it in the microwave for 4 minutes. And so after we put it in the microwave, we will check back in and I will show you what it should look like. Okay, everyone, so I took our bowl out of the microwave and then I also put it in the fridge for a few minutes because it was blazing hot. So the next thing we're gonna do is we are just going to pick up our cabbage leaves and we're gonna wring them out because we wanna get as much indicator out as possible. Okay. Squeeze them like that. All right, and I'll check back in after I've wrung out all of my cabbage leaves. Okay, everyone, so your indicator should be a violet color or a blue color. If your indicator is more blue than violet, then that's just because of the minerals in the Memphis water. So I just took a tablespoon and I'm just gonna put it in each of these little glasses. Before I do that, I'm gonna explain what each of these glasses contains. So here in this one, we have lemon juice. This one is a yogurt. This one here in the middle is water. This is an Ajax dish soap here. And then in this one, I will pour some bleach. I'm not gonna pour the bleach into the cup until it's time, just because bleach is toxic. For this one, I would recommend you get your parents or your older siblings to help you pour it in, because it can irritate your skin. If you get any on you, immediately you need to go ahead and rinse it off. But all right, let's go ahead and start pouring our indicator into some of these glasses. I predict that this one will be red because it will be the most acidic. This one, it might be somewhere in between red and blue. So we'll just see how this one comes out. This one will be neutral. So it should be just like a lighter blue color. This one will be more of a violet because it should be basic. And then this one, I predict might even be a bluish green because it is the most basic substance we have here. If you have any drain cleaner at home, I would recommend setting up a cup for that too, and then that one should turn a greenish yellow. All right, let's get started. Okay. I'm just gonna slowly drip it in. All right, can you see our red color for me? Oh yeah, that's awesome, check that out. Okay, so our lemon is indeed acidic. I'm very curious about this yogurt. Let's see how this turns out. Oh, check that out. That one's, oh, actually, let me move the bowl so you can see. Yeah, it's definitely turning like a pinkish purple, which would make sense. It should not be as red as our lemon. Yeah, it's like a nice little lavender purpley color here. Very cool. Okay, so now we are going to test our water. Oh wow, look at that. It's like a bluish green. After we go through all of these, we are going to go back to our last slide and interpret our results. Wow, I just can't get enough of that pretty teal. Can you all see it at home? Let's see. Let me step out of the frame. There we go. So you got a yogurt reflection happening. Yeah, that's what that one looks like. Just move this out of the way. Yeah, that one's turning pretty dark. Can you guys see that there? Yeah, it's turning more of that violet color we talked about earlier. Ooh, very cool. All right, so now I'm going to go ahead and pour the bleach. As you're pouring the bleach, just again, be sure not to get it on you, and then also don't put your nose directly over it. Try to keep it at a bit of a distance. Okay, that's enough. All right, everybody, let's see. Oh, there we go. Yeah. We've got that crazy yellow color. All right, so I'm gonna bring them closer to the camera one by one. So again, we see here we have our very red substance, our lemon juice. We have our pink here, just look at the top, don't look at the bottom, that's just yogurty and it hasn't touched the indicator yet. Yeah, on the top, we have more of like a pink color. Here we have a turquoise blue. It's a little difficult to see because of my shirt, it kind of blends in. We have our nice, go ahead and look at that top layer. Look, we kind of have two different layers happening. This is just soap that hasn't touched the indicator. And then up here, this is our more watery, our water and soap are interacting up here. That's kind of our dark violet. And then here, we have our nice light yellow. Yeah, very, very cool. So it looks like this experiment was a success. Let's go ahead again. I'm going to show you all that last slide so that you can all kind of compare it to this scale here for the red cabbage. Yep, so we see our red in the 0 to 1 range. And then this is more in our 3 range here. So these are acids for sure. Here are waters, like kind of like a turquoisey. So I would say it's between 5 and 6. So our water in Memphis isn't exactly neutral. Normally it would be, but here we have lots of minerals in our water. And then here we have like a tin almost. Look at that. Yeah, it's like green, dark blue. Yeah, like a tin. And then here we have like a 12, I would say, 12 or a 13. So yeah, experiment success. I'm really excited to see what you all determine the household items in your house are. I hope you enjoyed this experiment, and we hope to see you next time. All right, bye-bye.